Hello, my name is Jamison Porter. I'm a sophomore mechanical engineer at the University of Delaware, and this is my presentation on the mechanics of the differential, core principles, and modern designs. Today I'll be talking about the problem that a differential was invented to resolve, the principles of an automotive differential, and the components of the automotive differential. Then I will talk about the power flow, so the power flow when the car is going straight, and the power flow when the car is turning, and how do they differ. And then I'll be talking about the variations. I'll be talking about open differential mostly today, its advantages and disadvantages, and then some of the other types of differentials, why they were created, their purposes, etc. So the problem, how does a car corner? When a car corners, the outside wheel wants to spin faster and the inside wheel wants to spin slower. If you have a straight axle between both wheels, that means there's no differential. The wheels and the axle will act as a rigid body and all will have the exact same angular velocity. Because of this, the outside wheel and inside wheel are not spinning where they want to be and they will start to slip. So the differential is a system of gears that allows the outer wheel to spin faster than the inner wheel. Torque will follow the path of least resistance through the differential. The differential reduces tire wear. It'll help stabilize in cornering. It'll increase the drivetrain longevity, and it'll also help to support the suspension components of the car. So the drive shaft. The drive shaft is not technically part of the differential, but it is worth mentioning that it allows power to flow to the pinion gear. The pinion gear's entire purpose is to transfer that power 90 degrees. Since it is flowing straight back towards the differential and the differential needs to spin the wheels, the power is coming in perpendicular to the wheels and it needs to be transferred 90 degrees. These are the axles. Each axle is connected to each of the drive wheels. And these are the side gears, which are each connected to their respective axle. So the side gears will rotate depending on how the spider gears rotate, and transfer that rotation through the axle to the wheels. These spider gears are the main component of a differential. They are able to rotate on their own axis. You can see through the black bracket there, they have a pin, which allows them to rotate, but they also can orbit with the ring gear, which is the big blue gear. The purpose of the ring gear is to just take that power that's being converted from the pinion at 90 degrees and just spin the entire differential. So it'll spin with the entire differential casing on the car and divert that power into the spider gears. So power flow. When the car is going straight, the ring gear through the pinion will start to rotate and the spider gears will orbit with the ring gear because of the black brackets connecting them, but they will not turn at all. The spider gears will not rotate on their own. So this creates what is called a solid unit differential. So the differential is just spinning as a whole, basically, because of the pinion gear and the connections. So both wheels will rotate at the exact same speed. This story changes when the car starts to turn. So the spider gears will start to rotate on their own axis as well as orbit with the ring gear. And the result is an axle speed change between both axles. So one axle will speed up and one axle will slow down. So each wheel is going to be supplied the corresponding angular velocity so that the car the wheels can travel at the speed that they need to travel along that arc that I showed in the beginning. And this difference is linear. So depending on the input through the drive shaft into the differential, the outer wheel will start to speed up, as you can see on the top line, and the inner wheel will start to slow down, and this difference is linear. So however much the outer wheel starts to increase in RPM, the inner wheel will decrease in RPM. So the open differential. The pros of the open differential is that it is relatively straightforward to assemble, and there's really low manufacturing cost, and is extremely reliable. The biggest con of the different open differential is that torque is going to follow the path of least resistance. So if you have one of your drive wheels sitting on some ice, let's say, all of the torque is going to flow to that wheel because torque wants to follow the path of least resistance, which means your wheel that has no grip is going to be spinning on the ice, and the wheel that let's say, is not on the ice, it's on the road, is not going to receive any of the torque. So your car is stuck unless it was already moving. So here's some of the other types. There's a ton of different differentials, but here are the main ones. The limited slip differential, a newer one is called torque vectoring differentials. There's locking differentials and welded differentials, and they each serve their own purpose, and they vary mainly on reliability, complexity, handling or driver effort, and the cost of the differential, so the cost of manufacturing. So the limited slip differential kind of acts like an open differential. It is a series of internal clutches called the torsion gear system to create friction. The friction forces force some of the torque to the wheel with more grip. So it basically just it was invented to solve the biggest flaw of the open differential. Torque vectoring is, like I said, is really newer. Is a differential using electronic sensors and clutches to detect and push more power to the wheel in need. Um, as you can imagine, it's very expensive and manufacturing is complex, but the result is impeccable handling and cornering speeds because the computer is so precise. A locking differential is a differential that connects both wheels together with pins. It can be activated manually or automatically. So you can lock the differential so they both spin at the same speed, or you can unlock it to kind of have that open differential vibe. A welded differential is very similar to a locking differential, except it permanently joins both axles together, and the spider gears are physically welded. So that's the main difference between them is how permanent it is. Locking differentials are not permanent, while welded differentials are. Both of these are used in drag racing because you don't need to corner, or drift cars mostly. And torque vectoring is used a lot in EVs. And that is it for my presentation. A lot of my images were sourced from Sabin Civil Engineering, his video on differentials and how they work.